So now once we have the idea of just the rules of plain old numbered fractions, now we're going to take those rules and we're going to apply it to rational expressions, things with variables in them. Alright, so looking at this problem, we have 3x over x plus 1 plus 5 over x plus 1. So remember, the key here is that we have to have the common denominator. And in this case, we do have that common denominator. They're both x plus 1. So our answer is going to be over that common denominator, just like we did with the plain fractions. But now we have 3x as a numerator, and then we have a 5 as a numerator. So we need to add those things together, 3x plus 5. Is there any way that I can combine these? No, because these are not like terms. So our answer is here. Now, before we are finished, just like we did with the plain numbered fractions, you have to make sure that nothing will cancel. And in order to make sure about that, these have to be fully factored. So 3x plus 5, we cannot break that down any further. This is fully factored. And x plus 1 is also fully factored. So our answer for this problem is 3x plus 5 over x plus 1. Let's look at another one. Here we have a problem that says 2x over 2x squared minus 7x minus 15 plus 3 over 2x squared minus 7x minus 15. So again, we have to look to see whether we have a common denominator or not, and in this case we do. So we would write our answer over that common denominator of 2x squared minus 7x minus 15. And then we would combine our numerators. So our numerators here are 2x plus 3. Now, this is the answer, but it may not be the best answer. We have to always make sure that there's nothing that would cancel. So in order to do that, it has to be fully factored. 2x plus 3 is fully factored. There's nothing else we can do with that. But the 2x squared minus 7x minus 15, that's a trinomial. We might be able to factor that down some. So I tell you what, I'm going to show you a little bit of a trick, sort of. 2x squared, the only choices for that are 2x and x. Now, if one of these is going to cancel with the numerator, in order for that to happen, we'd have to have a plus 3 here, right? This is a little trick sort of to help you factor this trinomial maybe a little bit easier. And 3 times negative 5 would give us negative 15. Now all we have to do to check to see if this works is look at the middle term. In order to get the middle term, we have to do the outers. So that would be a negative 10x and a positive 3x for the inner terms. So negative 10 plus 3 would be negative 7. So this is the factorization. A lot of times you can let one of the factors on top help guide you as to what the factorization should be on the bottom, and they always double check it to make sure that it works. But now that we have this fully factored, we can see that 2x plus 3 cancels on top and bottom. So our final answer would be, in the numerator, we only have a 1 left. Remember, even though it doesn't look like there's anything there, you always have a 1. And in the denominator, we have an x minus 5 left. So our answer to this problem would be 1 over x minus 5.